All right. Good morning, everyone. I know that you are studying, ne? I'm having a live class, so I won't mind you being in here, but just speak politely, so ne? Softly, so that you don't get your voices captured on the live stream. Ne? All right, grade 12. We continue where we left off yesterday with our tree diagrams. For this one is grade 11 tree diagram where we are given two set of balls. We have three marbles, the blue ones, and then we have the two red ones. So the marble is taken from that bag, and the color has been recorded, and the marble is put aside. So the color has been recorded and the marble has been put aside. You don't take it back into the original bag. So the second marble is also taken out from the bag and the color is also recorded and also put aside. So the question says, draw a T diagram to represent the information above and show the probabilities associated with each branch as well as the possible outcome. So I'm going to start with 8.1. The first withdrawal. Let's see if I can just do it here. Two set of balls. So we have marbles, blue, first withdrawal, and then red. And then we start with the probabilities to say, in total, how many marbles did we have? We had 3 plus 2, which is 5. So for blue, we'll have 3 marbles out of 5. And then for red, we had 2 out of a total of 5. And then for the second withdrawal that we discussed yesterday, we have the same branches, blue and red. Even for this side, we have blue and red. Because the marble has been placed aside, it means it doesn't go back. So we will have, if the blue was actually removed, we will now have 2, and the total number will be 4. And then for red, you still have 2 out of the total of 4. And then if the red ones where the marble was removed at first, then we'll have blue, we will still have 3 out of a total of 4, because red has been removed and we only have 2 reds. And then for the red ones, we'll just have 1 out of 4. So this becomes your probabilities. So this branch will give us a blue and a blue, and then this branch will give us a blue and a red. And then on this branch we'll have a red and a blue, and for this branch we'll have a red and a red. In one bag, 3 of them were blue, 2 of them were red. And then if we withdraw them and be placed aside, we will have possible outcomes. There will just be 4 possible outcomes. And then the problem continues to say, determine the probability of first taking a red ball and then taking a blue marble in that order. So it means that they are looking for first taking a red and then taking a blue marble. They are looking for this combination. So which is this one. We look at the branch that will actually give us that. We look at this branch. Start with the red and then give us a blue. So if you want to find the probability of withdrawing a red ball, then a blue ball, you take it from our tree diagram. So it will simply be 2 over 5 because we're moving along the track, so we multiply. So this will be multiplied by 3 over 4. And then we use our calculator and see how much we get. Same 6, 2 over 5 multiply by 3 divide by 4. Our answer will simply be 3 over 10, which is in percentages. This is the same as 3%. Somebody can say this is the same as 0.3. So we have 30% chance of throwing a red ball than a blue ball. This is just to consider what we did yesterday as far as grade 11 concept is concerned. Hope everybody understands this. Then let me just save it for later. And then let's try other problems. We have another interesting one on the board. Let me see if it's clear. All of you guys who are online. Good. Now the problem we have here, we have A and B are 2 events, and then the probability that event A will occur is 0.4. So let us highlight this. The first part, the probability of A, event A happening is 0.4, and then the probability of event B happening is 0.3. The probability of event B is 0.3, and then the probability that either of A or even B will occur, which means it's an or B happening is 0.5. And then the first question starts and says, are events A and B mutually exclusive? And we said for events to be mutually exclusive, we need to make sure that the probability of A and B happening at the same time is actually 0. From the information that we have here, none of the information that we have is actually telling us this. So what we do in your formula sheet, we have, if you want to find the probability of A or B happening, it will be the same as the probability of A plus the probability of B, removing the probability of A and B. So after substituting this, all these values, because we see that we have the probability of A or B, the probability of A, the probability of B, and we get that this is 0, then we can conclude to say these 2 events are mutually exclusive. But for now, we cannot say. So let us substitute to the 0.58. Probability of A is 0.4. The probability of B happening was given to us as 0.3 minus the probability of A and B happening at the same time. And then if we simplify, we can add these two and transpose them to the left hand side. So we'll have 0.58 minus 0.4 minus 0.3, which will give us, if we transpose this to the other side, they will change the sign. So we'll get a negative 0.12, which is equal to negative the probability of A and B happening at the same time. We see both of them, they are negative. We can divide by a negative number or a negative 1, then we will say, therefore we can conclude the probability of A and B is actually equal to 0.12. Therefore, we can confidently say, right, the two events are not mutually exclusive. Why? Because the probability of A and B happening at the same time, it is not equals to 0. So that will be your answer for 8.2.1. And just give it a few seconds just to make sense of it, and then you can always go back to the video and go backwards so that you can be able to see if you missed out something. You can always send the question with a time stamp to say at this part that's where you got lost. We'll be able to revert back to you. Let us now move to are events A and B independent? I said to you guys, once you see this word, independent, you must think of the product rule. I'm going to write it on top there to say P, A, and B, for them to be independent, the probability of A multiplied by the probability of B must be equal to the probability of A and B happening at the same time. So already we have the value of probability of A and B. Let's see if we take probability of A multiplied by the probability of B. See how much we get. We get 0.3 multiplied by 0.4. And then you can use your calculator to multiply that. And it simply gives you 0.12. And remember, the answer that we got for probability of A and B was also 0.12. So we are saying the probability of A and B, yes, is equal to the probability of A multiplied by the probability of B events happening at the same time. The two values are equal to each other. So we can say, yes, the events are independent. Good. Straightforward question with a straightforward answer. So when it comes to such problems, you need to also remember that we have two most important formulas, which is this one. It is also shown on the formula sheet, but the one for independence, it is not there on the formula sheet, so you must remember it. This is to please remember this, and this only appears when we have independence. And then for mutually exclusive, always remember that for something to be mutually exclusive, it means that if two events are mutually exclusive to each other, it means they cannot happen at the same time. So the probability of A and B happening at the same time must give us 0. All right. We have a guest.
I also just want to be famous. I was thinking mutually exclusive is like when you're dating someone and you're exclusive, then you can't be with someone else. So two events that are exclusive won't be happening at the same time.
That's also a nice example.
I'm gonna leave now. Bye.
Plug that. That's also a beautiful example. I hope the example that Meme has just given is also true in our current society. All right, now let's move to the other set of problems that we might get as far as grade 11 probability is concerned is our Venn diagram. And then there's things that I also want us to talk about. Let's talk about the Venn diagram in general. Yeah, when you have, not focusing on this one specifically, let's say we have 3 events happening. So we have event A, and then event B, then also event C. So you'll have the intersections of the 3. This is A and B. This for A and B. And then this one will be for B and C, the intersection. And this will be for A and C. So the probability of A and C, the probability of B and C, and then this will be the probability of A and B, and then for this one, let's do a different color, blue one. This is the probability of A and B and C. The English people will find this as using and twice. So this is the probability of, called it the intersection of all of them. This is where all the 3 events are happening at the same time. And then when you want to fill in your Venn diagram, there is also right at the corner there, it will be probably the total. If you have a set of learners maybe picking up something, this will be the total will be at by the left hand side corner, and then anything outside would be, if you are using learners that are not involved in A, B, or C, you just put them outside to show that those learners were not involved in the 3 events. So once you see any number that is outside the 3 circles, you know that that number is actually those who are not part of those events that you are required to select, and then this will give you a total number. For example, you see here they're saying we have a survey was done among 8 learners on their favorite sports, so we know this total number will just be 8 for this one. But we'll also do that. Now let's use this information as an example. So I show you how we are supposed to do the Venn diagram. Let me just save this. Good. Let's take the information that we have here, and I'll also show you the strategy on how we fill in the Venn diagram. Pretty easy. We just have certain steps that we need to follow, and then we will be fine. Let me draw I'm gonna try to make it as big as possible. Right, we have a total of 80 learners. Now the survey was done among 80 learners on their favorite sports, and the results are shown below. We have 3 different sporting codes. We have rugby, we have volleyball, and we have chess. So I'm going to draw my 3 circles to represent every sporting code. And then I'll start with rugby, volleyball, and then chess. And then let's start with the first one. 52 learners like rugby. To make our life very simple, we'd like to start at the intersection where all of them are actually involved. So we'd like to start at the middle, then go outside. Start with where all of them are happening, and start with the two intersections, then move out to the bigger circle. I'll also elaborate why are we doing that. So we have 42 learners who like volleyball, and then we have 5 learners that like chess only. We're looking for the information that will put us in the center and we can move outside. Then we have 12 learners that like rugby and chess, but not volleyball. We have 15 learners that like volleyball, chess, but not rugby. And then we have X learners that like all 3 types. So this will be our starting point. X learners that like all 3 sports. So we know we have the value of X here. Let me just write it. That's our X. I hope it's visible. You can also zoom it. And then we have 3 learners that do not like any sports. So let's go and find the intersection. You can also mark it out so this information has been represented. This has been also represented. So there's a difference of only. When you say only, remember in an intersection, this intersection means that these are the learners who are taking volleyball and chess only. This part will mean these are the learners who are taking rugby and volleyball only. This intersection, this will be the learners who are taking rugby and chess only. So if they say, if you have a keyword like only, it means that this will be fine. If they say we have, let me just say for example, this one is saying 5 learners like chess only, then I know that I need to have 5 learners this side. They take chess only. So this number represents this part, not the intersection. So it's just 5. But I would like us to actually have begin from the intersection. Just to explain only, if they were to say 10 learners are taking volleyball only, then I can put 10 here. But if they were to say we have 20 learners who are taking volleyball, we cannot put 20 here because we need to consider the intersection, because there's also learners who are playing volleyball but also playing rugby and also playing chess. And then let me start from this one. I have 52 learners that like rugby, I have 42 that like volleyball, I have 5 that love chess. This one I've already played during the illustration. I'm trying now to get the intersections. We have 14 learners that like rugby and volleyball but not chess. So it means that we have 14 learners that like rugby and also like volleyball but not chess. So we can simply put 14 here. So if the question was if the statement was saying 14 learners like rugby and volleyball and it ends there, it means that from this 14, I was supposed to say 14 minus X to take away those that are actually playing chess. So that X was supposed to be removed. But the fact that they mentioned that but not chess, so it means that it's specifically for the learners that are playing rugby and volleyball. We'll also do more examples so you can be able to get a feeling of it. Remember, it is just our revision for grade 11. And then we have 12 learners that like rugby and chess, but not volleyball. So we have 12 learners that like rugby and chess. We have rugby and chess, so we have 12 learners this side, but not chess. So it means that this is used in a different wording because they are saying 12 learners that like rugby and chess. They like rugby and chess, but not rugby. So here rugby is not involved. There's no intersection of rugby So we put the number as it is. If it were to say 12 learners like rugby and chess, and it ends there but not volleyball, we're going to say 12 minus x to get rid of those who are playing volleyball. And then let's see if we can get another intersection this side. We have 15 learners like volleyball and chess, but not rugby this side. And then we can move into the big circles. We have 5 this side. For chess, 5 learners like chess only. Now let's take a look at rugby. This has been accounted for. 3 learners. Okay, we forgot about this one. 3 learners did not like any sport. So these ones were not involved in any sport, so they are just going to be outside. They are not playing rugby, they are not playing volleyball, and they are also not playing chess, so we are going to put them outside. So this has been accounted for. We are just left with 2. This one is saying 52 learners like rugby. You must see the difference between the chess and the rugby. The information, this one is saying 52 learners like rugby. That's all it says. There's no but not. So it means that when you come to rugby, you look at rugby and say, okay, I have 52 learners who are playing rugby. So you must go and say 52 learners who are playing rugby, and you subtract all the intersections. So because already these learners have been counted, you are going to subtract x and also subtract 14. So the number you are going to place there, use your calculator. 52 minus 12 minus 14 will give me 26. So I'm going to put 26 minus x. This will give me 26 minus x, because this was not saying only or saying but not. So we need to remove those that have already been counted during the intersections. And then what we left with is 42. We have 42 learners like volleyball. So we have 42 for volleyball, but there's no only there, and there's no but not. So it means that we are going to also do the same thing. Say 42, and then subtract all the intersection. We have the first intersection as 15, and the other intersection as 14, then minus x. So this will be 42 minus 15 minus 14, and then it will give us 13 minus x. So our Venn diagram has been completed, and is also placed in terms of x. So what is the next step? We need to go and find the value of x. The next question is going to come, is going to say, what is the value of x? Or they will say, show that the value of x is this value. If we are going to find the value of x, you are going to count everybody now. I want to start adding everybody. I want to see that those people must give me 8. The total number of learners must be 80. So I will start by marking them off. So I'm going to add them together. I have 26 minus x. I have 12. And I have 14. And then I have 13 minus x, accounted for. I have 15, accounted for. And I have 5, accounted for. Don't forget the one which is outside. Plus 3, they must give me 8. So this has also been accounted for. Now this is simple algebra. You take out the like terms. So I'll have 26 plus 12 plus 14 plus, this is 13, my handwriting is bad, plus 13, then plus 15, plus 5, plus 3, and the total number gave me 88. So I had 88, then I have a negative x, and then I have minus negative x. So this will give me a negative 2x, which must give me 80. And then, is there any other minus x? No. And then we'll transpose this to the other side. And then we'll have a negative 2x being equals to negative 88. And then we divide both sides by negative 2, divide both sides by negative 2, and our x. Okay, let's correct that. We didn't subtract that. So negative 2x, then we have 80 minus 88 because we had an 88 as such. So negative 2x will simply give us a negative 8, and our x will just be equals to 4. Our x will just be equals to 4. So now let us also verify our information. We started from the center where we had x that like all three types of spots. Our value was actually x. If they don't give you that, then you can just place the sx as a variable to make your life easy. Always start here. That's where we start. You must always start there. Then go to the intersections. Then go to the bigger circles and see. It will be much easier for you to solve that Venn diagram. Good. Let's see if we can get another Venn diagram before we go to questions. Yes, another one. This one is already done it for you. So, a survey was conducted among 100 learners at a school to establish their involvement in 3 codes of sports, which is soccer, netball, and volleyball. It has also been shown and the results were recorded. And it is shown below. So we have 55 learners that play soccer. We also have 21 learners that play netball. We have 7 learners that play volleyball. We have 3 learners that play netball only. We have 2 learners that play soccer and volleyball, and we have 1 learner that plays all 3 sports. So the information that has been placed here, I want us to verify it. We have 1 learner from the center. We have 1 learner plays all 3 sports. It has been shown from the center. This is fine. And then we have 2 learners that play soccer and volleyball. We have 2 learners that play soccer and volleyball. Soccer and volleyball. We have 2 learners that play soccer and volleyball. So what I'm asking you is, do you think this will be, are we going to place 2 here? We will not put 2 here. Why? Because it was not specific to say 2 learners that play soccer and volleyball only. So for us to get this value, we'll say 2, and then we minus the 1 that was already being counted for, and this will simply give us 1. And then this is done. Let's see for another intersection. We have 3 learners that play netball only. 3 learners that play netball only, netball only. It will come as it is because they mentioned that only in this regard. And then let's go to the second one, the third one. We have 7 learners playing volleyball. We have 7 learners who are playing volleyball. This is the second. We have 7 that are playing volleyball. So we have 7 minus this one intersection minus the other intersection, which is 1, and then we minus 2 because we already have counted those learners. So our total number will be 7 minus 1 minus 2 give us 3. So this will be 1. Please do understand, if we were supposed to put 7 here only if they said only, but they didn't say only, just said 7 learners play volleyball. And then we have 21 learners play netball. We have 21 learners that play netball. So 21 learners that play netball, we still have to find, remember that we have 100 learners, and then we have 21 learners who play netball. So we must have 21 learners who are playing netball this side. Right? And we see that we only have this side. So we have 21, and then minus, we must subtract 8, then minus 1, and then minus 2. Twenty-one learners that play netball. So we have 21 minus A, minus 1, minus 2. So let's simplify that. This will be 18. 18 minus A must actually give me 3. Remember, the 3 was given to us. So we're using this information to help us find A. So 21 minus 1 is 20 minus 2 is 18. So we have 18 minus A is equal to 3. Well, the 3 has already been given to us, and it was also shown there. You see that we have 21 learners that play netball, but we know that we have 3 learners that are playing netball only. So the value of A will simply be, we take this to the other side, transpose to the other side, we have negative A equals to 3 minus 18, and now our negative A will be a negative 15, so our A will just be 15. So this A here will just be 15. And then we have 55 learners play soccer. So we have 55 learners that are playing soccer. So we'll have 55 and minus the intersection, because they didn't say only, minus 15, minus 1, and then minus another one. So it's this one, and that's 15. So if you subtract those, just quickly do it with the calculator. 55 minus 15 minus 1, our answer will be 38. So we'll have 38. So when our Venn diagram is complete, I'm just going to remove the one that we have actually calculated. When we're doing calculation, I'll remove this. And remove that. Remove this. then so that we can have a neat. This was just one. Good. And then what is left now is E. So for us to find E, all the numbers, and they need to give us 100. So let me start with E. E plus 3 plus 1 plus 38 plus 1 plus 2 plus 3 plus 15 must give me a total of 100, and then when we add them together will be 3 plus 1 plus 38 plus 1 plus 2 plus 3 plus 15, which is 63. So I have E plus 63 being equal to 100. So those who are not interested in any of the spotting code will simply be 100 minus 63, which is 37. So it's very, very important for you to be able to complete this Venn diagram. I'm still saying it again. Always start at the center, and if the question has no, if the statement that is given to you, is not written only, please do also subtract the intersection where the diagram is actually passing, or your second is passing. Good. And then we have found our value of A, B, and E. So this E will be 37 letters. Go back to it, practice them, and then once you are comfortable, then you can try in different scenarios. So we're going to move forward. We're still going to do calculus as part of this session, because we were supposed to complete yesterday, but due to technical glitches, we couldn't. But we'll try to. We're not gonna try. We're gonna finish it. Come hell or high waters. All right. Now let's take a look again for practice purposes and see if you have actually understood what we have been trying to explain. So we have the probability that the first answer in a math quiz competition will be correct is 0.4. Let's look at this one. See, from the statement, you need to figure out if you are having a Venn diagram or you are having your continuous table, or you are having a diagram. Let's look at this one. The probability that the first answer in a math quiz is correct, it will be 0.4. If the first answer is correct, the probability of getting the next answer correct rises to 0.5. However, if the first answer is wrong, the probability of getting the next answer is only 0.4. So from reading the statement, I can see that we are having a tree diagram scenario. So let's start with the first one. The probability that the first answer in a math quiz, first answer being correct, and if it's not correct, it's incorrect. Let me call it I see, incorrect. So the probability that the first answer is correct will be 0.4. Remember, probability must add to 1. So the total probability here, it means the probability of that answer being incorrect will just be this difference of 0.4 minus 1, which is 0.6. Because it's either you are wrong, it's either you are correct or you are incorrect. There's no middle part, or the middle point for it's correct or incorrect. And then it continues. If the first answer is correct, the probability of getting the next answer correct rises to 0.5. If the answer is correct, the probability of you getting another correct answer will rise now to 0.5. So it means also the probability of getting an incorrect answer will be 0.5. However, if the first answer is wrong, which is incorrect, wrong sounds very harsh. Let's use incorrect. So, however, if the first answer is wrong, the probability of getting the next answer correct is 0.3. So this will be 0.3, and then incorrect will now be 0.7. If you look at the probability of this, it's 1. If you add this 1, these branches will actually give you 1. Even more when we're using marbles, and in those 3 branches that we had for 3 different balls, it will, when we add them together, they will always give you, the probability will always give you 1. Now that we have our tree diagram, we are sorted, we can answer any question. The next question is saying, calculate the probability of getting the second answer correct. Calculate the probability of getting the second answer correct. So it means we need the second answer to be correct. Even if the first answer can be correct. So it can be incorrect. Remember here, first answer correct, second answer correct. But the question wants the second answer to be correct. First answer correct, this one is incorrect. And this one we don't take. First answer incorrect, second answer correct. So we have incorrect and correct, the combination here. So it means these 2 branches are the ones that are going to give us the results. So when I said when you move along the branch, you multiply. So the probability of getting the second answer correct will be moving along the branch 0.4 multiply by 0.5 and then plus when we come to this branch, because we just want the second answer to be correct regardless of what we got on the first answer, then multiply by 0.3. Along the branch you multiply, across the branches you add. So we'll use a calculator and say we have 0.4 multiplied by 0.5. This will give us 0.2. Okay, just type the whole thing in the calculator as it is. 0.6 multiplied by 0.3. And then this will give us 0.18. And we add them together. We get 0.38. So we have 38% chance of getting the second answer correct. Yeah. Look for more problems. Go to previous question papers. Look for this set of questions, and then practice until you are perfect. Instead, you can still pose questions if you have any questions. And then let us see. I'm going to be a bit quick because there's gonna be a repetition of the same thing. Right. Another one we can use just to consolidate and see if we have understood will be we are given the probability of A and the probability of B. We're also given the probability of A or B. We've seen this type of questions before. So where A and B are two different events. The first question is, are the events A and B mutually exclusive? The fact that we need to know if they're mutually exclusive is because PA and B, it is not given, so we cannot say, so we need to go and calculate it. So we'll say, all right, we know that P, A or B, the probability of A plus the probability of B minus the probability of A and the probability of B. Then we substitute. We have probability of A or B, which is 0.8, probability of A, which is 0.6, the probability of B is 0.3, then minus probability of A and B, and then we have 0.8, 0.6 plus 0, is 0.9. Yeah? Probability of A or B. And then we transpose this to the other side. It will be our negative 0.1 is equal to the probability of A and B. Let's fix that. It's N. This is N. Don't do the same mistake in examination. And so the probability of A and B is equal to 0.1. So are they mutually exclusive? No, because this is not equal to 0. Good. I think we are fine now. And then let's conclude. I hope now everybody get a picture of how we do these problems. Straightforward, they come in the same format. You just have to know what you are looking for. All right, I also placed a continuous table so you can at least have one example. Like I said, this will be the totals. At the bottom and side will be the totals. So how many students are there at the college? So the total number will be the one at the corner, which is 960, the total amount. I hope everybody sees it. The total amount is 960. Let me just give it a few, see if we are still following. Good. Welcome those who are here. Total number will be 960 because it's total number at the corner. And then we have to find the females, we have 106. Remember, this is the total of this row, of this column. So 160 plus something must give me 192. So if you want to find A, you will simply say 192 minus 106. And this will give us 86. And then we come this side. Can we find E? Yes, because when we add this, they must give 160. We can find E. 960 minus 192. 768. You can take any root that you like. Once you get this, you can subtract the 2. 768 minus 422 will give us 346. And then when you add this 2, they must give you that. So we have 86 plus 346, 432. And then these 2, when you add them, they must give you this. Or these 2, when you add them, they must give you that B. Let's see if we're gonna get the same answer. 106 plus 422 is 528. That's 528 when you add it, or when you subtract 960 and you subtract 432, gives you 528. So all the numbers, they actually tally. Just remember the one at the corner is the total number of whatever we are measuring. So the statement was saying all students at a certain college undergo an annual HIV testing. The results of this year's testing are shown in the table below. How many students are there in the college? We'll have 960 learners or students in the college. Find the value of A, B, C, D, and E. We have done that already. I hope everybody understood how we find those values. And then 13.3 says, is HIV status independent of gender at this college? Is HIV status independent of gender at this college? Motivate your answer. Remember what I said. I said once you see independency, you are thinking P, A, and B is equal to PA multiplied by the probability of B. So you can select, you're in an examination, you can select a status. Whether you pick an HIV status, the one which is positive or negative, you pick one. And then from gender, you can pick male or female, any combination, because I'm comparing the status and they're not specific which status. So you can either pick positive or negative, and they are saying in terms of gender, they're saying gender. So they're not specific about which gender are they talking about. So I'm going to take positive. The probability of HIV positive, of the people who are HIV positive. Let's look at HIV positive. The total number of HIV positive, irregardless if you are a male or female, is 192. Remember, the total number is 160. HIV positive. I'm going to use the HIV positive status to check if the status and the gender are they independent. And then for gender, let me pick female this time. Female, that will represent my gender. It's now my female, total number of females is 432. because I selected HIV positive and female, it means I must also find the probability of being HIV positive and being a female. This is representing our status, and this is representing our gender. You can choose. You can choose to say HIV negative and a male, or HIV negative and a male and a female. It's up to you, as long as the gender and the status are represented, and then this will determine which one you look for. So the probability of HIV and being a female at the same time, HIV positive, here we are, and female at the same time is 86. I don't know if it's that's the intersection. HIV positive, female, they combine at 86. So the probability will be 86 over 960. Now we're going to multiply this using this formula to say, let us find the probability of HIV positive multiplied by the probability of being a female, and see how much you get. You get 192 all over 960 multiplied by 432 all over 960, and see how much you get. 192 multiplied by 4, 192 multiplied by 432 divided by 960 divided by 960 again, and then it gave me 0.09. And then let's look at this one, how much it gives us. 86 divided by 960. This gives me 0.0895. So if we round it off, it will be 0.09. So do you see now these two values are equal to each other? So it means that HIV status and gender at this college are independent. These are our calculations. You can just see this. Because P HIV positive multiplied by P female is equals to P HIV positive and female. Excellent. Good. Look at the last ones that I want you guys to actually, those who are online, and let me say good. Let's see if we can quickly do this one. I'm gonna give you in just a few minutes. Let me just give you only 5 minutes so I can also drink water. While we are doing this one, you verify if you're still online. Okay? All right, let's quickly do this one. I think now we are able to make sense of the Venn diagram. And we have a group of 33 learners was surveyed at a school, and the following information from the survey is given. We have 2 learners that play tennis and hockey and netball. Is the center, we are okay, good. And then we have 5 learners that play hockey and netball. So we have 5 learners that play hockey and netball, hockey and netball. You see why the number is 3, but here is 5. It's because they didn't say 5 learners play hockey and netball only. So we had a 5, and to subtract the intersection. And the intersection was actually 2. That's why we have that 3. So the intersection that passes here, from here it will be 5, then minus the first intersection, which will be 2. This will be 5 minus 2, which is 5 minus 2, which is 3. So we verify that this 3 is actually 5. And then we have 7 learners. 7 learners play hockey and tennis. So we have 7 learners that play hockey and tennis. Hockey and tennis. So we're going to have 7 minus 2, because they didn't say only. 7 learners play hockey and tennis. So it will be 7 minus 2, which will simply give us 5. And then we move on to the next one. We have 6 learners play tennis and netball. We have 6 learners that play tennis and netball. Netball and tennis, 6 learners. So we're going to move out this, subtract this intersection. So it will be 6 minus 2, which will just give us 4. 6 learners play tennis and netball. But if they said only, we'll just put the 6 as it is. And then we have a total of 18 learners play hockey. Remember, the total number here of these learners is just 33. A total of 18 learners play hockey. We have 18 learners that are playing hockey. So we're going to have 18, then minus 5, minus 2, minus 3. But if they were to say 18 learners play hockey only, then we'll put 18 as it is. But because they didn't say only, we're also going to subtract those we have already counted. So it's going to be 18 minus 5, minus 2, and minus 3. And this will give us 8. And then we have a total of 12 learners that play tennis. So we have 12 learners that play tennis. So we're also going to check the intersection of tennis. So it's going to be 12 minus 4. It will be 12 minus 4, minus 2, minus 5. You see, I'm using a calculator even myself, so that they can actually be accurate. So we have 4 learners play netball only. That's why we have the 4 coming in as it is. So what are we missing? We are missing E. So we're going to add all the numbers and see how much they give us. So we're going to say E plus 1 plus 5 plus 2 plus 4 plus another 4 plus 3 plus 8 must give us 33. We have E, we have 1, we have 5, we have 2, we have 4, we have 4, we have 3, we have 8. Everybody's accounted for. And then we add the numbers 1 plus 5 plus 2 plus 4 plus 4 plus 3 plus 8, 27. So we have E plus 27 equals to 33. This comes this side. Our E will simply be 33 minus 27, and then our E will be 33 minus 27, and this will give us 6. So if you can complete the Venn diagram, And then if they ask you any probability, you are able to take whatever you have here and then divide by the total number. It will be your probability. For example, if I were to ask you, what is the probability of learners taking all 3 sports? I will say the probability of all 3 sports will be 2 divided by 33. So it is very important for you guys to get these numbers correct, your Venn diagram to be complete, to make the next coming questions much easier for you. I think that's a wrap for probability. We will now move into calculus. So thank you very much. We need to practice and all the best in this topic. It will be an easy one, not that difficult, as long as you just stick to the basics and then overcomplicate things. Good. 5 minutes break. And then we'll start. Those who are already here, you can start. Don't solve this. This is what it's just a preview of what we're going to be discussing today. Yeah.
23rd of when Trump June. Yeah. It's not 22. I was also factorizing because I was seeing because the question was not wrong, but it wasn't wrong. Right, the question was x minus x minus x over x plus 3. Shane, you only want to do all as far as I understand this, I would x3 x minus 3, x plus 3, x minus 3. Right, it would be all x minus 3. Yes. Is it? But is the difference between yeah, sure. Yeah, sure. Yes, because I was thinking of the difference between two. Yes. No, they're not. This is what I was, yes, this is, yes, but they're not to be, oh, I understand. So, yes, so you're going to remove x minus 3. Yes. Yes, I know that. That's what my other friend. Yes, the same as yes, and then you will just stop it. This is what they're doing. Yeah. So now x minus 3 over x. Perfect. Which is easy. Just need to know this. In my head, I was doing this. No. No. This is wrong. This is wrong. This should be 6. No, it wasn't. But I wasn't getting it. Yes, you become this to be 6, so it would be fine. Which I know. You know, I like it.
Alright, this one is still fresh in our head because we just did it a week ago. Okay, so let's make sure that we consolidate it. We are able to do it thoroughly. We will be doing first principle and then using rules. Hopefully they will not say find the gradient of the curve, because they say we're not going to plot the curve. So we're going to just focus on these ones. First principle, first 4 marks or 5 marks, We don't flaunt that, we make sure. Good. Now let's try to find, we should stop trying. Let's find the first principle and the derivative using the first principle. Like we said, I said when you look at your formula sheet, we have the first derivative of f at x. Come on now. Is equals to the limit when h goes to 0, f at x plus h minus f at x all over Make sure you copy this formula as it is from the formula sheet. And then I said to you guys, just to avoid the mess, just on the side, let's go and find f at x plus h. So we are going to replace where we see x, we'll put f at x plus h. So our f at x plus h will be equal to x plus h. Remember this was x, so it's going to be x plus h squared, and then minus 3. Don't forget that minus 3. Yeah? Then you simplify just before you go and substitute. This will be x squared 2xh plus h squared and then minus 3. This is our f at x plus h. Then we go to our formula. Then we substitute. You can say equals to, but don't get rid of the limit. F at x plus h, it is now, I like to put it in bracket for now. Yeah? So as you can see that it's f at x plus h, and you still need f at x. And then f at x, what was given to us, also put it in bracket. Just to be on the safe side. Doing this will avoid making mistakes, especially in terms of the signs and so forth, or just substituting f at x plus h, forgetting to put in f at x. So you need to be able to come and see it again and add f at x. And then when we remove the bracket, this will be x squared plus 2xh plus h squared minus 3 minus x, because I multiplied this by a negative, minus x squared and then plus 3 all over h. And the limit when h goes to 0, the x will minus the x squared, the x squared will minus the x squared, and then negative 3 will, additive inverse is positive 3. So I'm just left with 2xh plus h squared at the top divided by h. And then I'm going to continue this side. And say this will be equal to, I'm going to take out common factor. I know we are taught to take out the highest common factor, but take out h. Né? I'll tell you why. It's 2x plus h all over h. So h is gone. The limit when h now goes to 0 is actually 2x plus h. And as soon as I substitute h equals to 0, h has arrived. It will be 2 where I see h, I'll put 0, the limit is gone. That's when the limit is gone, so our answer is just 2x. So please make sure when it comes to the first principle that you get it right, and then don't rush it. I'm not saying take your time, but don't really rush it. Make sure that everything has been accounted for, because now you know rules. If you don't get 2x, like you know you have to get 2x, and if you don't get 2x, you're going to get frustrated. Keep going back to the problem. So it's better to get it right the first time. Ne? To avoid panic. Good. What do we take from here? Make sure that the formula is written as it is. If you're not confident, go to your formula sheet. It's there in the formula sheet. Go to your formula, copy it as it is. On the side, go and find f at x plus h, then come back and find f at x plus h to make our life much easier. Good. Then comes the rules. We said when it comes to rules, so this is a combination of when we're learning rules and their notation. The notation are very, very important. So for the first one, if you are given y, please make sure, this is very important, make sure y is the subject of the formula. If you're going to differentiate dy, dx, if you're going to differentiate dy in terms of x, make sure that your y is in terms of, it's a subject of the formula. So this is saying differentiate y in terms of x. So you call it dy dx. This is your y. So as you are simplifying, this is already in exponential format, so there's no need for us to simplify. But if we were to simplify, let me say if, let's say, our y was equals to -3, then instead of this, we had the square root of x plus 7x. And then remember we said it must be in exponential format. So when I simplify it, it will still remain as y. Please don't simplify this one and differentiate this one. Leave it as y, and then this will be x to the power of 1/2 plus 7/x. And everybody in this line is actually in exponential format. We see a power, there is our power, we see our base, we see a power, but the power is 1, and here is our base. Then we can say we are in exponential format. That's when we can start differentiating. As soon as you differentiate, then it becomes dy dx equals to, looking at the dy dx is on the left hand side. The left dy dx is on the left hand side. It's no more y, it's dy dx, because you are starting to differentiate. You take this, you multiply by that, which will give us -3/2. And then we have x. Remember, we have to subtract 1 after multiplying the power by the coefficient. We need to subtract 1, and then this will give us a -1/2. And then this will simply give us 1 times 7 will just give 7. Then 1 minus 0 will be x to the power of 0, which is 1. So our dy dx is the same as that. If they say write this to the positive exponent, we can say -3/2. Because this is negative, you can put it at the denominator and leave it as positive. Plus 7. This is for what it was for this. Now let's go and do what is on the board. dy dx will be equal to just 2 multiplied by -3 will give us a -6, and then x to the power of 1, and then 2 minus 1 will just be 1, and then the same applies this side. We have 1 multiplied by 7, it will give us a 7, minus 1 is x to the power of 0, so dy dx will simply give us a -6x plus 7. Make sense? Capture. Let's move now to other problems. That's the rules of differentiation using the notation. So remember dy dx, y is the substitute of the formula, and then dy dx goes to the left hand side. Now with this one is dx. It says differentiate whatever is in that bracket. So if you look at whatever is on that bracket, it is not in exponential form. So as you are simplifying, you still write that dx. That dx will not be removed until when you are done differentiating. When you are still simplifying, keep the dx. Let's simplify first the bracket. We have x to the power of 3 minus 5x squared. So for this one, we can say this will be x to the power of 3, just to make things easy and people to understand what is actually happening here, minus 5x squared over x to the power of 3 minus square root of x. Let me just keep it like that for now. I'll come and simplify it. So remember we said if somebody will have a over c plus b over c, the fact that these two fractions are having the same denominator, you will keep the denominator and add the numerators depending on the sign. If it was minus, you will subtract them. So I'm doing the same thing. I'm just going backwards so that I can make my life much easier. Remember, my target is to make sure that I have exponential format. So my dx for this one will just be 1. And then for this, it will be 5x to the power of -1. Or somebody can come and say, this is the as 1 minus 5 over x. Still okay. And then this one will be the same as x to the power of 1 over 2. Remember, I square root to the power of 1 over 2 because there's a 2 here. So if we have a square root of x, there is a 2 here and there is a 1 here. So whatever is inside goes on top. Whatever is outside goes to the bottom. Remember that we also had an advert for Primora. If it's not on top, if it's not inside, it's on top. Ne? This one is saying if it's inside, it goes to the top. And then we can now simplify this further. So this one is already simplified. So I'm going to start differentiating. As soon as I start differentiating, the dx will be gone. So my answer on this, we said any constant, the derivative of any constant is 0. So this is 0. And then we're going to multiply this by that. It's going to be a positive 5, negative 1 times negative 5 will be a positive 5. And then x to the power of minus 2, because we're going to subtract 1 here after we have multiplied. Do the same thing this side. Multiply the coefficient by the power, negative half, and then x, and then we subtract the 1 from the power, and then it will give us a negative half. Good. If there are no further instructions, your answer is fine like this. But if they say leave it as a positive exponent, we can come and simplify it and say 5 to the power of, because you are negative, you put it at the denominator, and then your power will be positive now, but at the denominator. This will be minus 1 over 2, and then this will be x to the power of 1 over 2. Hope that makes sense. Good. Now those who did this and they still had minus x to the power of 1 over 2, because you're still not yet in exponential format, you still keep the dx until everything has been placed as an exponential format. And then after this step, we come this side, the dx is gone. Once you start differentiating, the dx must be gone. And please don't write this. It's incorrect. It just disappears. This says differentiate. It says differentiate in terms of x, whatever is on the bracket. So when you say this, you're saying differentiate what? What is in here? What are we differentiating? Unless if you want to come and be technical and say dx, then you put back the original function here and say the answer is this. I can give you that. But to make life easy, just remove the dx at the end. Hope it makes sense. Nah? Save it. As principle, who's what is that? Somebody committing suicide and okay, I'm doing this. Let me first principle because I want to show you how important it is for us to always do the right thing. Start with the formula. We want to do it until everybody understands that this is very, very important. The formula from the formula sheet. and then this on the side. And then if you do it on the side, just show it to us. Don't do it on the screen, man. It will be wherever I see X, I'll put X plus H. Simplify this. X squared plus 2xh, h squared, -1, 4x squared, 8xh, 4h squared. Make sure everything is fine. I'll just multiply everybody by 4. And then I come and substitute. -1, 4x squared, 8xh, h squared, x minus 1 plus 4x squared. Thank you very much, sir. And then everything over here. Don't forget the h. And then also don't forget the limit. Like I said, don't put the limit on the other side of the equal sign. Right? So the limit when h goes to 0. Now let's remove the bracket. I'm going to have a -1 plus 4x squared plus 8xh plus h squared. This multiplied by this will be a +1. This multiplied by this will be a -4x squared. And everything over h. And then the limit when h goes to 0. We have simplified now, don't rush it. This will subtract that. 4x squared will divide 4x squared. And I'm just left with 8xh plus h squared all over h. And then let's move in this side. We take out the common factor. Don't get tired of writing the limit when h goes to 0. Remove h. Then as soon as we substitute, then let me just change the color. As soon as we substitute h, the limit goes. Good. Make sure you are fast when it comes to such, no? And then let's do one set of rules. So we have the x, we have the y, the x. And then let's go with the x. first. I'm going to be a bit quick now. So we have the x, 2x to the power of 3 plus 5 x squared. So this, remember when we learned how to, as long as we are squared, we can easily start squaring this part first, raise it to the power of 2, and then it will give us 4x to the power of 6. And then we multiply this 2. When we multiply this by that, it will give us 10x to the power of 3 multiplied by 2. So it's going to give us 20x to the power of 3. And then we square this side, it will give us 25. If you still have trust issues, this is the same as 2x to the power of 3 open both brackets, use the FOIL method. When you multiply this by that, it will give you 4x to the power of 6. This by that, it will give us 10x to the power of 3. 10x to the power of 3. And then this will give us 25. So we finally have inside the bracket the x is equal to 4x to the power of 6 plus 20x to the power of 3 plus 25. Everything in exponential format. And then our answer is, because now we can differentiate 6 times 4, I think it's 34. And then x to the power of 5, because we removed 1. And then this will give us 60. And this will be x to the power of 2. And then the constant is 25, this will be 0. So this becomes our final answer. Good. Let's see if we can find dy dx. Y is equal to 3x to the power of 4 minus 7 over x plus 2 multiplied by the cubic root of x squared. So we need to simplify this. So as we're simplifying, please make sure that you're still keeping it as y. So if we have y 3x to the power of 4. We have minus 7x to the power of negative 1. Well, this one's at the bottom. And then we have a 2 multiplied by x. We said whoever was inside will go to the top. The one which is outside will go and become a denominator. So this was a plus. Né? Good. Let's check if we're doing the same problem. Yes, this was a plus. So now everything is in exponential format. We're going to differentiate now. So you have dy over dx being equals to 12x to the power of 3. Then plus, because this multiplied by this would be positive, plus 7. And then x to the power of negative 2. We subtract the power by 1. And then plus, this multiplied by this will give us 4 over 3. 2 over 3. And don't, if you can't use your mental maths, don't force it. Just use a calculator. Nobody will know. See, you are there writing an examination. We will not know. Just use a calculator. 2 over 3 and minus 1. negative 1 over 3.
Okay, do you know how you remember dy over dx? Because whenever you're dating someone, you have to ask yourself, why are you dating them? Then they become dx.
That's nice. I like Mem's examples every time. They have to do with the relationship.
Just because I'm single, ne? That's how I remember. That's how I teach independent and dependent variables.
Good.
Access, 'cause
I hope you remember that. Yeah?
you have if you're dependent on something.
Good. And then if they continue to say write this as a positive exponent, which is not mentioned here, just for interest's sake, you can simplify this. 7 over x squared, and then plus 4 over 3 x to the power of 1. And then we're good to go. Hope is sorted. I'm going to do one first principle. I love this one first principle because it tends to make learners start pushing themselves. But once you get something like this in an examination, please also don't panic. Yeah? Let me save this. This will be our last first principle problems. And then we'll start doing rules for the next coming, maybe, let's say 30 minutes. And then after 30 minutes, we'll stop the live. And then we'll do, immediately after that, after 30 minutes, we'll be doing functions. Both the grade 11 and the grade 12 inverses. And then you can go and write your examination. All right, let's try. Let's see. Formula limit h goes to 0, f of x plus h you said we're gonna go to the side. Let's go to the sides. That's straightforward. Substitute. It's too big. The bracket is too big. The reason why I like to put them in brackets is because when everything is positive, things are very straightforward. But as soon as you are given a negative, and with most instances, the examiner will give you something with a negative, just to catch you off guard. Always protect them with, guard them with the bracket. Eh? It's like a prayer. Got it. And then we need to simplify this, but we don't want a double story in mathematics. So I'm going to do this. Negative 2 x plus h. This will be a plus. Negative side negative will be a plus. 2 x And then let me do this. Bigger bracket, divide by h. This division is this one. I want to simplify the one on top, so I don't want to have double stories like I'm building a mansion. Alright, and then what happens now when you want to add any fraction, we need to go and find the lowest common denominator. So our lowest common denominator for those two, everybody must be represented, will just be x plus h. So I'm going to have my lowest common denominator will be x plus h. The denominator, if I take the lowest common denominator and I divide it by this, I'm going to be left with x, so I must multiply this by -2. And then the x was not there, I must multiply it by x. And then plus, this is my plus 2, yes 2. If I divide the lowest common denominator, I divide it by x, it will just give me your x plus h. So you just multiply by what your denominator didn't have. If you look at this, this fraction actually had x plus h the denominator, it didn't have x. And the lowest common denominator has x and x plus h. So we just multiply the denominator by what it didn't have. Don't forget again that we said this will change now. Let's change our multiplication, our division to multiplication, and this will just be 1 over h. We can simplify the left hand side. We get an eraser to make space. And then let's use algebra just to simplify. So it's equal to the limit when h goes to 0. So this side, it will give me a -2x, and then I multiply this by that, it will give me a +2x. Multiply this by that, it will give me a +2h, and everything over x multiplied by x plus h. And then don't forget, I'll multiply by 1 over h. I'm still simplifying. I'm not rushing it. When h goes to 0, this looks like something else. So this will divide that. This will subtract it. Subtract it, not divide. And then I'll be left with 2h over x plus h multiplied by 1 over h. H will divide h now. I'll now be left with the limit when h goes to 0, which will be equal to 2 over x, then x plus h. And then now I'm going to substitute. Let me change the color, get rid of the limit. I'll have 2 over x, then I have x, then h as a 0 here, there, and my answer will just be 2, and then x multiplied by x will just be x squared. So in exponential format, this will be 2x to the power of -2. Which is fine, because this was given as a negative. Please check that one out. It's very interesting. It needs you to remember your lowest common denominators. The same applies to the one of square root of x. We'll just do that one just for for interest sake, né? When we get time. We good? And then yes. I took this question from one of the provinces that wrote, I think, a couple of weeks ago. So the examiner gave them this problem. dy, the straightforward dy dx, but look at that. Is y the subject of the formula? Remember, dy dx means we are differentiating y in terms of x. Is y the subject of the formula? When you look at this, no. So we need to do some work before we can start finding dy dx. And then, but because we are grade 12, we're able to make y the subject of the formula easy this side. Let's take out a common factor this side. I think our common factor will be y, and then x minus 2. And then this side, you see we have a difference of 2 squares. So this will be x minus 2, and then x plus 2, and then our y will simply be dividing both sides by x minus 2. To divide this x minus 2, and then our answer will be x plus 2. So what looked like a very difficult problem is actually very simple calculus problem, and then our dy dx will simply be 1. Because when you multiply this, it's going to give us 1 times 1 is 1. Then minus 1 is, and the constant, with different the constant will actually give us 0. So dy dx equals to 1. Makes sense? Straightforward. So, like I was saying, make sure that your y is always the subject of the formula before you can start differentiating. Now let's move to, I think we're gonna get another one for dx. All right, with this one, very nice. So we said, as long as you haven't differentiated your dx remains as it is, so we will have your dx, yes, and then we have the root of 32 over s cubed. So what we can actually start first to say is to say, okay, this is 32. It's 32. Take this as to become from the denominator. It will be to the power of negative 3. And then dx, and this will simply be 32 x to the power of negative 3, 1 over 3. Ne? Don't say negative 3 over 3 because this one is inside, because remember there's also a 32 there. So you must be very careful. 1 over 5, not 3. 1 over 5, because it was root of 5. And then this will give me dx and then 32, 1 over 5, and then x to the power of negative 3, and then we can say multiply by 1 over 5, loss of exponents, it's just loss of exponents, and then we have 32, root of 5 of 32 is just 2. And then we have x to the power of negative 3 over 5. And then our answer will simply be a negative 6 over 5. Then x to the power of, if we minus 1 here, it will simply give us a negative 8 over 5. I don't know what's wrong with that. You always use a calculator. So once you start differentiating, you can remove the dx. But as long as you're still simplifying, keep the dx in there. Dx if we implement the loss of exponent correctly, using another way, we can say 32 over x to the power of 3 multiplied by 1 over 5. So your dx is 1 over 5 over x to the power of 3, also multiply by 1 over 5. The one on top, if you put that in the calculator, it will give you 2. It was 2 to the power of 5 is 32. Don't forget the dx, because we are simplifying. And at the bottom, we have x to the power of 3 over 5. And this simply will give us 2 x to the power of negative 3 over 5. And then we move it aside. Hope it makes sense. Good. There's twice, so you need to also be versatile, especially when it comes to the loss of exponents. Good. I think that's calculus for us, first principle and the roots can be able to bear it. But let's also check. We also had problems in class that we encountered that has to do with the different types of roots. So we can use the previous question papers to also find different and more challenging problems. I try to take for as many problems as possible. Let's look at this one. I think we've made a scenario like of this caliber to say if one to y, because y is already the subject of the formula, this will be y. Y being equal to negative 4x to the power of 5 divided by x to the power of negative 2 plus 3 of x divided by x to the power of negative 2. And then my y, since I'm still simplifying, it will be a negative 4. When you divide exponents, you keep the base and you subtract the powers. So this will be 5 minus negative 2, which will give us a 7. And then on the other side, we have 3. We divide the exponent. So this will be a negative, this will be x to the power of positive 3. And then we say dy dx, because everything in the exponential format will be equal to 7 times 4, which is 28. 28. We have 28, and then x to the power of 6. And then we have 3 times 3, which is 9, and x squared. This is our final answer. When you look at them at the first glance, they look intimidating, but they actually straightforward questions. Same applies to this one. The dx, let's simplify that. In the bracket will be x to the power of 3 over 2, because there was 2 inside there, and then we have b squared. Anything that doesn't have x will be regarded as a constant. Anything that doesn't have the coefficient of x will be regarded as a constant. So this b squared, because we're differentiating in terms of x, that's why we are having dx. That's why the dx is coming from. Differentiate this, whatever is inside the bracket, in terms of x. If it doesn't x, then it's a constant. So our answer will simply be 3 over 2, then x, if we minus 1, this will give us half. That's our answer. This is 0. Even if they can add m squared or a million z squared, 0. Doesn't have x, 0. Hope it makes sense. As long as the coefficient of x is not there, you don't differentiate, you are 0, you are a constant. Hope that makes sense. Yeah? And then let's move on. This will be our last slide for live video, and then we'll take 30 minutes break, or I can make it 15 minutes or 10 minutes, but let's make it 30 minutes, and after 30 minutes then we can start with functions. And then if you haven't eaten lunch, please, you must go and eat lunch, because I'm about to drain your energy. Right, the last slide. Very interesting indeed. You are given y is equals to 4x squared minus 3, and you are given 2xt equals to 7. What's the catch here? The catch is you are not more differentiating in terms of x, you're differentiating in terms of t. So anything that doesn't have t will not be regarded as a constant. But firstly, y must be the subject of the formula. So what we can do here is to say, okay, let's take this equation and then make x the subject of the formula. So you'll have 2xt equals to 7, and then we want x to be the subject of the formula, so we'll divide by 2t, and then our x will simply be 7 over 2t. Then we go to the other equation where we see x, will put 7 over 2t. So I'll have y being equal to 4. What is x? X is 7 over 2t squared, and then minus 3, and then y will be equal to 4, and then this will be 49 because this is squared, and then 4t squared, and then minus 3. Simplify that. The 4 will divide the 4, so I'll have 49 over t squared minus 3. So my y will simply be 49. I bring this to the top, negative 2 minus 3. And if now they're asking me for dy dt, I'll say my dy dt will simply be negative 2 multiplied by 49, multiply this by that, and then t to the power of negative 3, because I'm going to subtract 1, and then this is a constant, 0. So dy dt will be 49 times 2 quickly is 98, negative 98 2 to the power of negative 3, or somebody can also say dy dt as a positive exponent will be a negative 98 and then t to the power of 3. Awesome stuff. Yeah, see you again in 30 minutes. I will also share the link with you guys on the WhatsApp group. Yeah?